into second definition. Why second definition? You are very happy with first one. If lower Riemann integral is equal to upper Riemann integral, then we say it is Riemann integral. Yesterday we have seen. But the total is based on LPF and UPF. Both are based on small m or capital M. If they don't exist, then we cannot apply that technique. So we have second definition. So what is second definition is, according to second definition, we have to follow a sum called Riemann sum. Earlier we have seen Darboux sum and Riemann lower integral, Riemann upper integral. But now this is what is called Riemann sum. What we have seen earlier, that was Darboux sum. What is Riemann sum is, it is denoted by P is a partition, F is from A, B to R, that story. All those conditions are the same. So, and P is any partition. You know, P is a partition of AB. Then the Riemann sum is denoted by F of, this is denoted by SPF in some textbooks, defined by summation F of CSIR delta. Find Darboux sum means follow LPF, UPF. Oscillatory sum means WPF. This is Riemann sum. What is CSIR? Where CSIR is the tag. It is what is called as a tag of IR. What is meant by tag is, any arbitrary point of an interval is what is called as the tag. For example, any student of this class, if I say, I did not fix, I did not say roll number 1, I did not say either Sarita or Nagamani, I did not call by any name. I am saying any student of this class, respond. Sir will be asking you to respond. Is it not in between? Any student, that any student of this class is called tag of this class. TAG, tag. Tag means it can be any arbitrary point of the interval is what is called as the tag. So tag can be left end, tag can be right end, tag can be midpoint. It can be anything, any point in this interval. In this interval, how many points will be there? Infinitely many points will be there in this interval. All these infinitely many points, if you take any one, that is what is called tag. Then F of CSIR and delta R. What is delta R? Width of the interval, right hand minus left hand. So in this, we are not using any small m or capital M R. So this is applicable for all types of functions. But whereas LPF, UPF concept is only when F is bounded. Then only we can find small m or capital M R, helps lower Riemann integral, upper Riemann integral, and so on. So this concept is applicable for all. Then how Riemann integration is defined? Riemann integration is defined as, we say F is Riemann integrable according to second definition. F is said to be Riemann integrable. That concept also got invented by Riemann. This also by Riemann only. That is for bounded. This is for any type, whether bounded or unbounded. For bounded also you can apply. Unbounded also you can apply. For any type of functions you can apply. F belongs to R of AB, then F is said to be Riemann integrable if and only if given epsilon greater than 0, there exist I, a real number, and a partition P of AB such that SPF as n tends to infinity goes to I. What is SPF? This. In other words, given epsilon, there exists this such that summation, that is modulus SPF minus I less than epsilon whenever norm P, modulus of norm P minus 0 less than delta. What is norm P? Maximum of the deltas. So as this is also denoted by the symbol, this is like a given epsilon limit fx equal to L model. When do we say limit x approaching a fx equal to L? Given epsilon, there exists a delta such that fx minus L less than epsilon whenever x minus a is less than delta. Instead of x minus a, you are having norm p minus 0. Here we are using n tending to infinity because as norm p goes to 0, it is same as n tends to infinity. We have discussed earlier. So as number of partitions are becoming more, width decreases. What is norm p? Length of the interval. That is maximum of the deltas. So what is norm p? Maximum of these deltas. So n denotes number of partitions. As you increase number of partitions, the width automatically decreases. This width decreases means norm p decreases. Decreases means it becomes very, very small. So norm p approaches 0 implies n tending to infinity. Your apartment only you can see 1200 SFT. You can divide into 2 parts, 3 parts, 4 parts, double bedroom, triple bedroom, any number of bedrooms. The space is the same. As you increase number of partitions, then the size of the rooms decreases, is it not? Similarly, as you increase n tends to infinity, number of partitions becomes large, width decreases. Norm p denotes width, maximum of the deltas. We have discussed earlier, we have done problems also. So delta 1, delta 2, and delta. As deltas becomes very small, norm p becomes very small. Small means approaching 0. So instead of norm approaching 0, we are using this. So this is also equivalently saying norm p approaches 0, SPF is equal to I. This is like fx minus L less than epsilon whenever x minus a less than delta. Limit definition. Limit norm p approaching 0, SPF should approach I. So this is how the second definition has come into picture. So generally we use this. Then there is another best application of this. That means, in other words, limit n tending to infinity, summation f of xi r delta must be equal to I. This I is what is called the integral value of fx dx. So if you calculate this I for bounded using first definition and same bounded using this, you will get same answer. This fixed constant is called integral of this function. So this has given rise to one of the interesting results. Based on this, you are getting questions. So this is summation is same as integration. So summation of infinite things is nothing but integration. If you say simply summation n equal to r equal to 1 to n, let us say f of r, it is nothing but in summation, that is f, let us say r square. Then what will you get? A 1 square, 2 square, and so on up to n square. It will stop. But as n tends to infinity, here n r means natural number. We are taking r equal to 1, r equal to 2, r equal to 3, and so on. Selected numbers. But if what will happen to limit n tending to infinity as r equal to 1 to n and r belongs to capital R? It is a real number. So r equal to 1. After 1, what is the next real number? We don't know. You cannot say 1.1, 1.000001 is there. Somebody says you take 1 crore zeros and 1, 2 crore zeros, 1 will be there, less than that. So what is the next number after 1? Real number, we don't know, but it is there. So then how to find out this? This we try to find out using integral concept. So the sum of the infinite things is nothing but the integral. If it is selected 1 to n, selected natural numbers, then it is summation. So the sum of infinite things is nothing but integration. Summation is same as integration. So this is the concept. Now, coming back to our present one, important result. If you take your AB interval as 0 to 1, and if you take your H, which is delta 1 equal to delta 2 equal to delta n is equal to H, which is b minus a by n, 1 minus 0 by n, 1 by n. This reduces to limit n tending to infinity, limit n tending and xi r. If you tag it at the right end, what is the IR interval? If you divide, this is 0, 1 by n, 2 by n, 3 by n, and so on. What will be the last one? N by n. What is preceding one? N minus 1 by n. So this is the nth subinterval. What will be rth subinterval? R minus 1 by n and R by n. This is IR. So if you take IR, is nothing but R minus 1 by n, rth subinterval, R by n. If you put R equal to 1, you will get 0 by n, 1 by n, first subinterval. Put R equal to 2, you will get 1 by n, 2 by n, and so on. Then if you tag, what is meant by tag? You can tag either at the left end, your XIR is any point. You can take left end, right end, or anything in between. So if you take in particular, when n tends to infinity, whatever tag you take, you will get the same answer finally. As I said yesterday, when you go in flight, if when you travel on the road, everything makes difference. So small building, big building, and so on. But when you travel to heights, then all appears to be same. So negligible. Whether you tag at left end, right end, or any point as n tends to infinity, whatever tag point you take, it makes no difference in the value. So to this, I am tagging at R by n. Then the definition becomes summation R equal to 1 to n, limit n tending to infinity, f of xi r delta r is equal to 0 a to b fx dx. If you substitute in this, all these values, what will you get? Limit n tending to infinity, summation R equal to 1 to n, f of R by n. I have tagged at right end. That means my XIR is right end. You can also take left end. You can take midpoint. But because its value is the same, I am tagging. This is my H. H is nothing but 1 by n. A is 0, B is 1. Because interval is 0 to 1. So we get this as the special case. H means 1 by n. So the summation is for R. So you can take 1 by n out. H out. H means 1 by n. Summation 1 to n f of R by n is nothing but equal to 0 to 1 fx dx. Very, very interesting result. The summation of this over the interval 0 to 1 will give you this result. You remember this form. We are getting questions from this area. How we are getting? Let us see one of the applications of this. This is one of the best applications of this. I'll try to work out. So limit n tending to infinity. You cannot even imagine that that question is from this area. You remember this form. So the value of question, limit n tending to infinity, 1 by n, sin pi by n, sin 2 pi by n, and so on, sin n pi by n is equal to dash. Given in one of the papers. How will you get this? So this is in which form? Limit n tending to infinity, 1 by n, summation 1 to n, sin r pi by n. You can see r equal to 1, first one, sin pi by n. Second term 2 pi by n. Third term 3 pi by n. Nth term n pi by n. Rth term r pi by n. This is in the form limit n tending to infinity, 1 by n, summation f of r by n. Okay. Now, according to this formula, this should be equal to 0 to 1 fx dx. Simply, according to the previous one. Limit n tending to infinity, 1 by n, f of r by n is this. According to second definition of Riemann integration. What is f of r by n? It is nothing but sin pi r by n. What is f of x? Sin pi x. So 0 to 1 sin pi x dx. What is sin pi x integral? Minus cos pi x by pi, 0 to 1. This is minus cos pi plus 1 pi. Cos pi is minus 1. Minus into minus 1 plus 1. 2 by pi. So given in many papers, this is how you can work out some questions based on this. I'll work out one more, which is given in another paper. So try to practice the questions like this. Limit n tending to infinity. Next question. 1 by n plus n square by n plus 1 whole cube. N square by n plus 2 whole cube. And so on. 1 by 8n is dash. You cannot even imagine that it is integration. So always remember our R should start from 1 to n or 0 to n minus 1. So using this, we have to predict the nth term. First term, this you take it separately 1 by n because n plus 0, 0th term. Remaining you can take first term, second term, third term, n square by n plus n whole. First term n square by n plus 1 cube. Second term n plus n square by n plus 2 whole cube. Last term, second term n plus 2, nth term n plus n whole cube. Numerator is fixed for all. N square is common for all. If you simplify this, you should get back this. If you are not getting back this, you have to again continue until you get that. So let us see this. But if you simplify, what will you get? N plus n, 2n whole cube is 8n cube. Is it tallying with this or not? Yes. 1 by 8n. So you can write. This can be read. This is 0 anyway. This is limit n tending to infinity summation n square by n plus r whole cube. R ranging from 1 to n. Can cross check. N square by n plus 1 whole cube, n plus 2 whole cube, n plus n whole cube. It's tallying with this. This can be rewritten in the form. Take n common, n square, n common. If you take n common, cube is there. So n cube 1 plus r by n whole cube. R equal to 1 to n. This is limit n tending to infinity. 1 by n summation 1 by 1 plus r by n whole cube. So this is summation f of r. So this is 0 to 1 fx. What is f of x? F of r by n is 1 by r 1 plus r by n whole. So what is f of x? 1 by 1 plus x whole. That is 1 plus x whole power minus 3. Integral 0 to 1 fx dx will be equal to 0 to 1 plus x whole power minus 3 dx. 1 plus x whole power minus 3 means minus 2 by minus 0 to 1. So 1 by minus 2. 1 plus 1 whole power minus 2. 1 plus 0 whole power minus 2. 1 by 2 square. This is the point.